To finish subtopic 7.1, we're going to have a look at some nuclear stability trends. So having a look at how it is that we can determine whether something's more likely to be a beta minus, beta plus, or alpha emitter. So the first thing is just looking at this graph again about stable nuclides. That's sort of our stability region, so we can sort of group it into anything that sort of sits in this region here, something that sits in this region here, or generally speaking anything that sits up the top there. Now the way to describe it here is that if it's something that's on the upper side of that that stability region, then we'd say that it's neutron rich. And something that's neutron rich means it has lots of neutrons, so we're going to see that in those cases they will tend to lose a neutron, so a neutron becoming a proton and an electron, and so generally speaking in this region we'd have beta minus emitters. Not surprisingly, on this side they would be described as being proton rich, and again, so proton would then become a neutron in order to become more stable, and so these ones would tend to be beta plus emitters. Now anything that's sort of in this region up the top here, basically it's just if it's sort of either this side or this side of the region of stability, it's generally going to just have too much mass. So anywhere up the top is basically just going to be tend to be alpha emitters. Not always. There will be some beta and beta plus, beta minus emitters up in that top end as well, but generally speaking the large ones, you'll find that most of them are going to be alpha emitters. So the first trend we're going to look at is that half of the stable nuclei that you can see on that graph have even numbers of neutrons and protons. So we're not talking just an even number of protons or an even number of neutrons, they have both even numbers of protons and neutrons. And to sort of put that into perspective, only 5 have both odd numbers of protons and neutrons. So you can see there the fact that there's something about even numbers that's important. So anything that has both odd protons and neutrons is generally not going to be stable. And finally, something else there as well is that you can sort of see it on the graph a little bit. You'll notice that in some regions, say there's one there, there's another one there, there's a few regions where we've got quite a lot of isotopes that are stable with the same atomic number. So generally speaking, elements with even numbers of protons or even atomic numbers so elements with even numbers of protons are the most abundant in the universe, or tend to be the most abundant in the universe. So there's the first trend. So it's all about the fact that even numbers tend to dominate when it comes to stability. The next one that we're going to look at is a bit of an odd one. So this one is sort of taking it a step further, I guess, and it's when either the number of protons or number of neutrons when it is one of the following values, it tends to be stable. So it's now not just about even numbers, it's about a very specific list of numbers those numbers being 2, 8, 20, 28, 50, 82 and 126. Why those numbers? I'm not sure. If you want to go and have a bit more of a look into that, you could, but just as a general trend, isotopes that have those numbers of either protons or neutrons tend to be stable. Even further than that, so isotopes that have both protons and neutrons, both proton and neutron numbers as one of those magic numbers, they tend to be really super stable, highly stable. So we're calling these magic numbers just to identify that there's something about them. So these ones tend to be highly stable and also tend to be very abundant in the universe. So just something to keep in the back of your mind, that isotopes aren't all created equal. There's some that are more stable than others. There are some elements that are more stable than others. You can even see, just as a side note, you can see there's a gap there in the graph and a gap there. So there are some elements that don't have any stable isotopes. So there are some trends in the stability of isotopes, and they're the key things to just sort of store in the back of your mind to be aware of about the stability.